Good evening and welcome to this video for the 2021 Level 2 Algebra paper. So like my last three videos, I do not actually have the marking schedule for this particular exam. So I will not actually know the exact grading for each question. And there also is the possibility that I do make some mistakes during this walkthrough, which I would appreciate if you do see anything that I have made a mistake. I would appreciate if you can just leave it in the comments so we can correct that later on. Alright, so question 1, simplify each expression, leaving your answer with positive indices. Alright, so in this case, we're just going to simplify the numerator first. We have 3y to the power 4, so everything inside the bracket is going to be raised to the 4th power. So this is equal to 3 to the power 4 times y to the power 4 divided by 3 times of y to the power negative 1. And 3 to the power 4, we have 81. Times y to the power 4 divided by 3 times y to the power negative 1. We know that y to the power negative 1 equals to 1 over y, and therefore this can be translated to, so 1 over y to the power negative 1 is just equal to y to the power of 1, so therefore we can say this is 81 to the power of, times y to the power of 5 over 3, which is 27 times y to the power of 5. Alright, so question number 2. So we have 8 times y to the power of 27 to the third root. So this is just saying that something times by itself 3 times is going to give us 8 times y to the power of 27. So in this case, we're just going to take everything inside this the cube root into the 1/3 power. So in this case, we have 8 to the power of 1 over 3 times y to the power of 27 to the power of 1 over 3. 8 to the power of 1 over 3 is 2. Y to the power of 27 to the power of 1 over 3 is just 1 over 3 times 27, which is 9. So this is 2 times y to the power of 9. And judging by these two questions, I would say if you can get both of the questions right, you might be able to get a merit grade, while 2 correct answers could be achieved. Question B, a quadratic equation has solution of x equals to negative 2 over 3 and x equals to 4. Find the original equation, giving your answers in form of ax squared plus bx plus c equals to 0. A, b, and c are whole numbers. So in this case, we know that the roots are x equals to negative 2 over 3 and x equals to 4. So we can write this in the form of x plus 2 over 3 times of x minus 4 is equal to 0. Since in this equation we'll see that clearly that x equals to 4 and x equals to negative 2 over 3 are solutions of this equation. And now all we need to do is expand out these two brackets and we'll clearly see our a, b, and c values. So if we expand out, we'll get x squared minus 4x plus 2 over 3x minus 8 over 3. And in this case, we can simplify this a little bit. So we have x squared minus 4x, minus 4 plus 2 over 3, x minus 8 over 3. So in this case, we want our a, b, and c to all of them to be whole numbers. So if we're trying to get whole numbers, then we need to multiply everything by 3, since we have fractional terms in our equation. So in this case, we'll have 3x squared minus 3 times of 4 plus 2 over 3 times of x minus 8 equals to 0. And 4 plus 2 over 3, so we have 4 plus 2 over 3. 4 times 3 is 12 plus 2 is 14, so that's 14 over 3. 14 over 3 times 3 is just 14, so this equals to 3x squared minus 14x minus 8 equals to 0. So therefore we have a equals to 3, b equals negative 14, and c equals to negative 8. And that should be our final answer for this question. And this should be a merit level question. And you could get an achieved if you do not write it in whole numbers. If you just give a equals to 1 and b equals to 14 over 3 and c equals to negative 8 over 3, then you might only get an achieved. So whole numbers, you need whole numbers to get the full mark, since it specifies in the question that we need whole numbers for a, b, and c. Alright, so question C. Consider a quadratic equation in the form x squared minus 3kx plus 2k squared, where k is a non-zero constant. Show that one solution is twice the other. Alright, so while looking at this question, there's two very clear ways you can do this question. The first one is clearly we can just simply just factorize the two solutions, which is just writing it out in terms of two brackets, and we can get equal to 0, and then we can clearly see our two solutions. So we have 2k squared is c, negative 3k is b, and a equals to 1. So we're looking for two constants that multiply to that multiply to 2k squared and add to negative 3k. So AB, we'll call AB the two solutions, is 2k squared, and A plus B is negative 3k. So in this case, okay, if we solve this simultaneously, we should see that in this case we'll have our two solutions will be the 2k and k. So we'll have x minus 2k times of x minus k, that equals to 0. And if you want to verify that this two brackets multiplied together will give you this, we can verify that. So we have x times x is x squared minus xk minus 2kx plus 2k squared. And if it will give us x squared minus 3kx plus 2k squared equals to 0, which indeed does match this original equation we have there. So we have our first solution, which is x equals to 2k, and our second solution is x equals to k. Clearly 2k is 2 times of k, so clearly 2k is double k, so QED, so we have proved. So the second way we can do this is we can simply just use the quadratic formula and then plug in our a, b, and c values. So we have x equals to negative b plus or minus square root of b squared minus 4ac all over 2a. So in this case, we'll have x equals to negative b, which is positive 3k, plus or minus square root of b squared is negative 3k whole thing squared, which is 9k squared, minus 4 times of a, which is 1, times of c, which is 2k squared, all over 2a, which is 2. So x equals to 3k over 2 plus or minus 1/2 of square root of 9k squared minus 8k squared is just k squared. And this will give us x equals to 3k over 2 plus or minus k over 2. So our first solution is when it's going to be a plus sign. So we're going to have x equals to 3k over 2 plus k over 2. And that's clearly equal, that's clearly equal to 2k. And our second solution is when it's going to be a minus sign. So we have x equals to 3k over 2 minus k over 2, and that's k. So we get the same two solutions. It doesn't really matter which way you do it, but you're going to get 2k and k as your two roots to the solution. Clearly 2k is double of k, so therefore we have proved we have proved the statement that this one solution is twice the other. And for this question, usually in level 2 there are 2 excellence questions per question. So I would say that since there's only one more question after this one, it's usually in the style of achieve questions and then merit question and then excellence questions. So it's more likely that this is indeed an excellence question. So that's when you have proved that x equals to 2k and x equals to k, and then you're saying that 2k is clearly double of k. That will give you the excellence grade. To get an achieve grade, at least, I would say if you can get up to it's a pretty tough one. I'm not too sure because it's really low number of lines in the working, especially for the first solution. So it's pretty tough to say where the merit and achieve parts are. But if I have to say, I'll say to get it achieved, if you can just if you can show some evidence of understanding that the addition of the roots is negative 3k and the multiplication is 2k squared, that could get an achieve, but I'm not sure. I'm not sure about that one. And I guess any minor mistake could get you a merit. If you accidentally make a small mistake, maybe you get negative 2k and negative k as your two solutions, that could get you a merit grade instead of an excellence grade. Yeah, but then again, I'm not 100% sure on that one. Consider the following two curves. So we have x squared equals to y squared plus 1, y equals to x minus 1 times x plus 1 minus 2. And the question asks us to find the coordinates of each intersection point of the two curves. Alright, so for this question, okay, we're just going to write down our two curves. So we have x squared equals to y squared plus 1. And on the second curve, we're going to expand the brackets. So we have y equals to x squared negative x plus x is 0, so that's just x squared minus 1 minus 2. So we have y equals to x squared minus 3. So in this case, we can make x squared the subject for both of the equations. So we have x squared equals to y plus 3. So that's from this equation. And from this second equation, we clearly have x squared equals to y squared plus 1. So we have x squared here and we have x squared here. That means that these two must be the same. So we have y plus 3 equals to y squared plus 1. And this just becomes a simple quadratic if we make this if we make this equation equal to 0. So we have y squared minus y minus 2 equals to 0. And we can simply factor this as y minus 2 times y plus 1 equals to 0. And therefore, we can clearly see that y equals to 2 and y equals to negative 1. And to find the coordinates, we need in the form of x comma y for our intersection points. So we're going to substitute y equals to 2 back to any one of those equations we had, either equation 1 or equation 2, in order to find the x value. So we can say that x squared equals to y squared plus 1. So therefore, we can say x squared equals to, if we say y equals to 2, so if y equals to 2, 2 squared is 4 plus 1 is 5. So x equals to plus or minus square root of 5. So remember, if you're taking square root in this case, square root, negative square root of 5 squared is 5, and positive square root of 5 squared is also 5. So there's two different solutions here, so just keep that in mind. And we can try for the solution of y equals to negative 1. So for y equals to negative 1, we have x squared equals to y squared plus 1. Negative 1 squared is 1, so we have x squared equals to 2. So x squared equals to plus or minus square root of 2. So the points of intersection we can clearly see is square root of 2. Sorry, what am I doing? Okay. So we have four intersection points in this case. It's just two possible x values for every one of those y values. So we have plus or minus square root of 2 and y equals to negative 1. So we have square root of 2, negative 1. That's 1. And we have negative square root of 2, negative 1. We also have positive square root of 5, comma 2. And we have negative square root of 5, comma 2. So those are our 4 points of intersection. So we should have 4 points of intersection. And if you get all 4 of these points correctly, that should be an excellence level grade. To get a merit level grade, I'm thinking if you can get 2 out of 4 points, 2 out of the 4 points, that's a merit grade. And the reason you would only get 2 out of the 4 points is if you only take the positive root. So if you just set x is equal to square root of 5 here and x equals to square root of 2 here, then you're only taking the positive root, then that will only be a merit grade. And if you want an achieved grade, if you just find y equals to 2 and y equals to negative 1, I'm pretty sure that should be sufficient evidence for an achievable grade, since you are that shows evidence of manipulating the expressions and then forming a quadratic equation and finding y equals to 2 and y equals to negative 1. Alright, so I have to look at question number 2. Simplify x squared minus x minus 12 over 4x plus 12. So this is whenever you get a question like this, you obviously know you need to factorize, okay? So you're going to have, on the numerator, we're going to have two numbers that multiply to negative 12 and add to negative 1. And we clearly see that that's going to be x minus 4 and x plus 3 all over 4x plus 2, 4x plus 12. Notice that 4 is a common factor of 4x plus 12, so we can actually bring the 4 outside. So we have x minus 4 times x plus 3 divided by 4 times of x plus 3. And as we can see here, we have x plus 3 and x plus 3 cancels out. So this will just simplify to x minus 4 over 4. This should just be a simple, straightforward, achieve level question. Write 5x over x minus 3 minus x minus 4 over x plus 2 as a single fraction in the simplest form. So in this case, we're just going to do our cross multiplication and then we just form our single fraction. So we're going to have 5x times of x plus 2 minus of x minus 4 times of x minus 3 all over x minus 3 times x plus 2. 5x times x plus 2, we get 5x squared plus 10x minus of x squared minus 7x plus 12 all over x minus 3 times x plus 2. So we just continue to simplify. So 5x squared plus 10x minus x squared plus 7x minus 12 all over x minus 3, x plus 2. And then 5x squared minus x squared is 4x squared. 10x plus 7x is positive 17x, and minus 12 divided by x minus 3 and x plus 2. And we want this in our simplest form. So then, okay, so the things you should be checking in this case is that whether you can factorize 4x squared plus 17x minus 12, and then if you can get anything that can cancel out with one of the bottom expressions. So we can try the factors of 4, so we have 4x and x. Then we're just looking at numbers that can multiply to negative 12, and then overall they can add to positive 17. So if we can find anything here. 2, 6 and 2 doesn't work. 4 and 3. No. 12 and 1. No, that's 16. 6 and 2. Sorry, 6 and 2. 3 and 4. 3 and 4 is going to give us 12 and 16. No. 6 and 2 gives us... No, okay. So I don't think we can factorize it any further. So this one, we should just leave it here. That should be our final answer. That should be fine. And this should be a merit level grade. So to get an achieved grade, achieved could be getting somewhere up to here. That could be an achieved. Right, so Jessica is investigating a compounding interest. She wants to know how long it would take for an investment of $1,000 to double in value to $2,000. She forms the following equation. So R is the rate of return on the investment as a percentage, and D is the time that the investment will take to double in value in years. So if an investment takes 11 years to double in value, what is the rate of return? So if you just read what these variables are, you'll have a pretty good understanding and approach to solve the question. So it says D is the time that the investment will take to double in value. So it takes, and then the question tells us that the investment takes 11 years to double in value. So clearly we see that D equals to 11. And once we have 11, we can rearrange the equation for R. And once we rearrange the equation for R, we can find the R value, and that will simply give us our rate of return on the investment. So 2,000 is equal to 1,000 times 1 plus R over 100 times of 11. Not times 11, to the power of 11. 2,000 divided by 1,000 is 2, and that is equal to 1 plus R over 100 to the power of 11. So we can take the power of 1 over 11 on both sides. So we have 2 to the power of 1 over 11 is equal to 1 plus R over 100. So therefore R over 100 is equal to 2 to the power of 1 over 11 minus 1. So therefore R is equal to 2 to the power of 1 over 11 minus 1 times of 100. And if we simplify this, we do need a calculator for this one, so just bear with me for a second. Sorry, just give me a second. I don't know where I placed my calculator, so I'm going to have to use my phone today. Apologize. So we have... Okay, sorry for the delay. 2 to the power. 1 divided by 11 minus 1 times 100. Alright, so I'm getting on this calculator, I'm getting R equals to 6.5%. Yeah, that's rate of return, I'm getting 6.5%. And this should just be, okay, this is split into parts, so that will be just part number 1. So part 1. And looking at part 2, so by making D the subject of the expression, show that D equals to log 2 over log 1 plus R over 100. So that's just pretty straightforward, okay, very, very typical NCA question. So first things first, you got to get rid of the 1,000 on the right-hand side. You divide both sides by 1,000. So 2 equals to 1 plus R over 100 over D. to the power of d. And then we can take the log of both sides. So we can say that log 2 is equal to, you take the power down, so d, so the power becomes the coefficient, so d, and then you take the log of 1 plus r over 100. And then you can divide both sides by log of 1 plus r over 100, so d equals to log 2 over log of 1 plus r over 100. And that is proved, so that's the exact same as what they wanted us to show, and that's what we have here. That will be the part number 2 for this question. And does this continue on? Yes, it does. Okay. So we have, in her research, Jessica comes over a simple but approximate rule for calculating D, the time that the investment will take to double in value. It is commonly called the rule of 72, and it states that D equals to 72 over R. Jessica wonders how close the values of D from the rule of 72 are to those calculated using the actual expression, which is D equals to log 2 divided by log of 1 plus r over 100. So we want to show that the value for r that calculates D is a solution to 2 to the power of r minus 1 plus r over 100 to the power of 72 is 0. So in this case, what we want to prove right now is we want to prove if we just add 1 plus r over 100 to the power of 72 on both sides, we'll see that 2 to the power of r is 1 plus r over 100 to the power of 72. So this is our target equation. This is basically what we want to prove. Okay, so that's our target proof. And in this case, we can just see that d equals to 72 over r. So simply rd is equal to 72. And if we make r the subject, we'll see that r is equal to 72 over d. And 1 over d is equal to log of 1 plus r over 100 divided by log of 2. So therefore we have r is equal to 72 log of 1 plus r over 100 divided by log 2. And that would be our r in this case. Alright, so we want to somehow prove that 2 to the power of r equals to 1 plus r over 100 to the power of 72. And right now we have, what do we have right now? We have r equals to 72 log of 1 plus r over 100 over log 2. Alright, so in this case, if we look at our target equation, we can actually manipulate it slightly a bit more. So we can take the log of both sides again on our target equations. We have r log of 2. So remember, the power becomes the coefficient, and we take the log of the base, and that's equal to 72 log of 1 plus r over 100. So simply we can see that r is equal to 72 log of 1 plus r over 100 all over log 2. And you see here, this is what we got from our d equals 72 over r, and this is our target expression. So we say left hand side equals to right hand side, and therefore we have proved. And that's our final answer for this question. And in terms of grading for the questions, it's pretty tough to see what NCA is looking for. So okay, so that's question 2. It is kind of strange, but if you can, okay, I was thinking that these two parts by itself was worth an excellence grade. So if you can get both part 1 and part 2, that should combine to get you an excellence grade, with any one fully correct part giving you a merit grade. In terms of the second part, I think this could just be an excellence by itself, but I'm not 100% sure. So this could just be an excellence question by itself. But once again, disclaimer, this is not 100%. I do not work for NCA, so I do not know what the exact grading for each question. This is just based off my educated guess, and that's what I would say in particular for this question. Alright, so question 3 wants us to consider a cube with size of p centimeters, and the volume of the cube would be p to the power of 3 centimeters cubed. So that would just be volume equals to base times width times height. And the surface area of the cube would be 6p squared centimeters squared. So Jung Yang wonders if it's possible to change the dimensions of the cube to make a cuboid that still has the same volume. First, he tries doubling the length and halving the width and keeping the height as 2p, keeping the height as p, sketched below. Using algebra, find the volume of this cuboid. So volume is equal to base times width times height. So in this case, we have volume equals to, choose black pen. Okay, so volume equals to b over 2 times 2p times p. In this case, we'll see that volume equals to, the 2 and the 2 here cancel out, so it's just p to the power 3 centimeters. And this will just be a simple achieve question here. The volume of the cuboid below is given by the expression p minus 4 times p plus 5 times p minus 3. It wants us to expand and simplify this expression. So we're just going to expand one bracket at a time and being careful to not make any simple mistakes. So we see that volume is equal to p squared plus p minus 20 multiplied by p minus 3. And now we just need to multiply through by p minus 3. And then we'll see that volume equals to p to the power 3 minus 3p squared plus p squared minus 3p minus 20p plus 60. So volume equals to p to the power 3. We have negative 3p squared plus p squared is negative 2p squared. And negative 3p minus 20p is negative 23p plus 60. So that's our final answer for this question. Okay, we've expanded it and simplified this expression. And this will be, this could just be a, achieved or merit level grade, but I'm not 100% sure. I'm just going to leave it as that. Next, Jung Yang tries adding an amount a to the length and then taking off the same amount from the width, keeping the height the same. Are there any values for a in which the volume of the cuboid will be the same as the cube? So remember, the volume of the cube is volume equals to p to the power 3. So what we're just trying to solve, we're trying to solve the expression p minus a times of p plus a times of p equals to p to the power 3. That's what we're trying to, that's simply the only thing we're trying to solve here. So all we need to do is we need to expand out. So we have p squared, negative ap plus ap is 0. So we have p squared minus a squared times of p equals to p cubed. And if we multiply through by p, we'll get p cubed minus a squared p equals to p cubed. P cubed cancel each other out. And a squared times of p equals to 0. So clearly we can see that the solution is a equals to 0. And therefore and if a equals to 0, it's just a cube, right? If you have a equals to 0, then that'll just be p times p times p, which is a cube. So therefore we're going to say this: there is no possible solution for a for the volume of the cuboid to be the same as the cube. And that's our answer for this question right there. And that would be a merit level grade. I'm pretty sure for this one. To get an achieved. Getting up to here, that should be an achieved. But I think you do need a statement to say something like this to get a merit. So just remember, sometimes I probably haven't done this very well throughout my walkthrough so far, but it's really important. Sometimes NCA marks people down, if they just don't explain at the end. For example, if you just get up to a squared times p equals to 0 and then you just stop, then they might be oh, you didn't communicate, you didn't actually answer the question, and that might bring you down, which is very important, to always explain clearly what you're doing and then link your final answer back to the context of the question. Sometimes it's pretty important. Yeah, that's what I would say. So Jung Yang realizes that the surface area of the cuboid will not be the same as the surface area of the cube unless he also changes the height. He decides to make the height of the cube 10 centimeters. He wants to find out in which value of p would result in the cube having the same surface area as the cuboid. To do this, he needs to form and solve an equation for p. If the surface area of the cube is the same as the surface area of the cuboid, show that 2p squared minus 2p plus a squared equals to 0. Remember that the surface area of the cube is 6p squared centimeters squared. So in this case, it's very similar to the volume question, except now we're dealing with the surface area. So all we're just doing is just saying that the surface area equals to 6p squared, and that 6p squared is equal to the surface area of the cuboid. So we need to find an algebraic expression for the surface area of the cuboid, and that's just simply counting up all 6 sides and then using just adding up the areas of the sides together to get our expression. So in this case, we're going to look at let's look at this face and this face to begin with. So we're going to have p plus a times of 10. So surface area equals to 2. Remember, there's one side that we can see and there's the other side we cannot see. So that's 2 times of 10 multiplied by p plus a. And if we want to look at this side and that side over there, we'll have p minus a times of 10. And remember, there's 2 sides, so we're going to add 2 times of 10 times of p minus a. And also we have this top side and the base. And that would just be p plus a times of p minus a. So that would be plus of 2 times of p plus a times p minus a. And then all we need to do is just simplify the expression. So surface area equals to 2 times 10 is 20. 20 times of p plus a is just 20p plus 20a. And that's added to 20 times p minus a, which is 20p minus 20a. And that's added to 2 times of p plus a times p minus a. We solved this in the previous question. That is just p squared minus a squared. So we can simplify some expressions here. So we have, that's 20a. So we have positive 20a and negative 20a cancel each other out. So surface area equals to 40p plus 2p squared minus 2a squared. And then we say that surface area is equal to 6p squared. So 6p squared equals to 2p squared plus 40p minus 2a squared. And then 4p squared minus 40p plus 2a squared equals to 0. And if we divide by a common factor, which is 2, we'll have 2p squared minus 20p plus a squared equals to 0, which is our target expression. And this will probably be an excellence question, where an achieved level grade would come if you can write the expression for the surface area, but not simplified. So that's be achieved. Surface area, if you get it and simplified, that'll probably be up to here. You'll get a merit. As mentioned in part I, if the surface area of the cube is the same as the surface area of the cuboid, then 2p squared minus 2p plus a squared equals to 0. By using the discriminant, find the largest possible whole number value of a that could be used in this context. Use this value to find the dimensions of both the cube and the cuboid. So explain your reason clearly. So clearly, in order to there to be a solution for a p, we clearly need the discriminant to be greater than 0. So b squared minus 4ac is greater than or equal to 0. So we have 2p squared minus 2p plus 2a, plus a squared equals to 0. And then we have our discriminant is b squared minus 4ac, and that's equal to 400 minus 4 times of 2 times of a squared. That's equal to 400 minus a squared. So 400a squared, 400 minus 8a squared is greater than 0. 400 is greater than 8a squared. 50 is greater than a squared. So then a must be at least 7. 400 is so. However, okay, we up to this step, which is good. Okay, that's great. But then also, we need to make sure one more thing. And the other thing is that we need p minus a to be greater than 0. Since if p minus a is less than 0, then this side of the cube would be negative, and that's not possible. So that's our second condition, right? So our first condition is that there's real solutions. That's going to yield us this equation. And our second condition is that p minus a greater than 0. We know that the expression for p will be using the quadratic formula. So we're going to say that p is equal to 20 plus or minus square root of our discriminant, which was 400 minus 8a squared, all over 2a, which is 4, So p equals to 5 plus or minus 1 over 4 square root of 400 minus 8a squared. And therefore, this must be greater than, in this case, I've talked myself into a circle. So we have p minus a must be greater than 0. So we have p minus a is greater than 0. So in this case, we have p equals to this. So then all we need to do is we need to say that 5 plus or minus 1 a squared, that's p minus a is greater than 0. So in this case, we know that clearly that 400 minus 8a squared, we know that that expression is greater than 0 for the real solutions. So therefore, we're just going to take the positive value for this root. Okay, so we're going to say that 5 plus 1/4 square root of 400 minus 8a squared, it is greater than 8. So then 1/4 square root of 400 minus 8a squared, it is greater than a minus 5. And then we can square both sides. So 1 over 16, 400 minus 8a squared, it is greater than a squared minus 10a plus 25. And we can multiply both sides by 16. So we have 400 minus 8a squared is greater than 16a squared. 16 times 10 is negative 160a. 25 times 16 is 400, if I'm not mistaken. Yeah, plus 400. 400 and 400 cancel out. And then in this case, we'll have 24a squared minus 160a is greater than 0. So then we will have a times of 24a minus 160 is greater than 0. So we have when a equals to 0 and a equals to, let me just do this. A equals to 6.67. We know this expression equals to 0, so expression equals to 0. And if we draw a positive parabola, we can see where our roots will lie. So we see this. And sorry, that's not very accurate. Okay, we'll see something like this. That will be our 6.67. That will be 0. And since we want this to be, we want this to be, sorry, this is, I made a mistake, okay. So 16a squared minus 160a, if we add 8a on both sides, sorry, this should be the other way around. Boop. And that should be the other way around. Yeah. Apologies. And therefore, if we look in between these two roots, that will be when our expression is less than 0. So therefore, a is between 6.67 and 0. And so we have our two conditions. Our condition 1 is a is less than or equal to 7. Okay, that's fine. And then the second one, we need to say a is less than 6.67. So therefore, the highest possible integer is 6. And we need to solve the equation to finish the question. So we say that 2p squared minus 20p plus a squared, which is 36, equals to 0. And I believe we need to use the quadratic formula for this one. So we have p equals to 20 plus or minus square root of 400 minus 4 times of a times of c all over 4. So p equals to 5 plus or minus 1/4 of 400. 400 minus 4 times 2 times 36. Root 112. And we can rewrite this as 5 plus or minus 1/4 times root of 16 times root 7. And that gives us a final answer of 5 plus or minus, square root of 16 is 4, times 1/4 is 1, so that's just plus or minus square root of 7. And that will be our answer for the question. So we have, to find the dimensions of the cube, so we have p equals to 5 plus or minus square root of 7. And that is our answer. We want dimensions of the cube and the cuboid. Okay, so in this case, so obviously one of these solutions won't be correct because we want everything to be positive. So we have 5 plus or minus square root of 7. So we have 5 plus root 7 and 5 minus root 7. And we had a was equal to 6. So therefore this is our p-value. So p equals to this and p equals to this. And 5 minus root 7 minus 6, that is less than 0. So this is an invalid solution. So we're looking at 5 plus square root of 7. So our dimensions will be, if we go back here, it will be 10 times of p plus a times of 10 p minus a. So we're running out of space a little bit, but should be able to fit. So we have 5 plus root 7 plus 6, 5 plus root 7 minus 6, and 10. So that would be 11 plus root 7 minus 1, and 10. And that'll be our dimensions of the cube. So that's a pretty challenging question, I would say. Very challenging question, especially for level 2. But we did eventually get there at the end, which is good. And that would be an excellence level grade if you can get the final answer. To get a merit level grade, if you can find a equals to 6, that's certainly going to give you enough evidence for a merit level grade. Achieve level grade, if you can use consistency and use a is less than or equal to 7. If you use consistency, you could get a achieve level grade for using this one. And yeah, I think that's reasonable. Right, so that was a pretty challenging paper in my opinion. So especially that last question was pretty challenging in my opinion. There was a little bit of abstract thinking that needed to go on with, especially with this side. So a lot of people commented that they forgot about that second condition. So a lot of people only used the a is less than or equal to 7, which is a very easy mistake to make. Since especially that's also highlighted by the fact that the question only says to use the discriminant. So that's also a little bit like, I don't really like that wording, since by using the discriminant refers to only using b squared minus 4ac, but the only thing you can obtain by using b squared minus 4ac is that a is less than or equal to 7. That's the only thing you can obtain. However, in reality, you have to use the quadratic formula as a whole. So that's what we did in number 2. We used the quadratic formula as a whole, and then by using the quadratic formula, we found the second condition, which was a is between those 6.67 and 0, and that gave us a equals to 6, not 7. So it is not trying to say anything, but didn't really like this last question, especially in terms of I think it was a little bit more difficult than what I would normally expect for a level 2 question, and also especially with this wording here with the using the discriminant, like that throws off a lot of people, since they don't think that they need to use the quadratic formula. If they got rid of this, if they just got rid of that, then if they just got rid of this entire statement, that would make it a bit better. But yeah, so that is a little bit of something I would criticize, but other than that, I think it was okay. So yeah, some questions you had to like, yeah. Question 1 wasn't too bad, I would say. Question 1 is just being able to manipulate expressions, and this question was pretty straightforward. Question 1C. So all in all, I would say this paper had some easy parts and some hard parts. So yeah, that's all I can say. So I hope you enjoyed watching this video, and I hope to see you all in the future.